Let's try another one. Okay, so this one is saying to verify that 1 minus cosine squared x times 1 plus cotangent squared x equals 1. Now, if you wanted to, you could distribute these, but the moment I see the number 1 with a trig function squared, I'm hoping, right, fingers crossed, I can use a Pythagorean identity, right? And that's one of the reasons that we have to have them memorized, is because at this point, if you don't have them memorized, you're like, I don't know what to do. All right, so let me check to see. I'll do the cosine squared one first. So let's change colors to show you the work I'm going to do. One of the Pythagorean identities is sine squared x plus cosine squared x equals 1. Okay, so I want to get the cosine squared x to be on the same side as 1 with some algebra. So I'm going to subtract cosine squared x from both sides. And when I do, I'm left with sine squared x equals 1 minus cosine squared x, which if you look, right, that is what I have. So I'm going to go ahead and do a little work here, right? 1 minus cosine squared x is the same as sine squared of x. So let's go ahead and replace 1 minus cosine squared x with sine squared of x. Now I'm going to go ahead and keep the 1 plus cotangent squared x for now, right? But all of this work that I did was to replace that first term. All right, so now let's do the same thing for 1 plus cotangent squared x. So one of the other Pythagorean identities is 1 plus cotangent squared x equals cosecant squared x. Now this one requires no manipulation. You'll notice in the parentheses, I'll use a different one, where you know these parentheses, that's already there, right? 1 plus cotangent squared x is already there. So I'm just going to replace it with cosecant squared x. So copy down the sine squared. And this is going to become cosecant squared x, right? Now, again, I want this to be 1, so I'm not there yet. So that was my second step. But I notice I have cosecant. Yeah, I know it says cosecant squared, but cosecant is the reciprocal of sine. So I'm going to copy down sine squared, but I'm going to rewrite cosecant squared as 1 over sine squared x. And similar to what I said on an earlier problem, that if you use one of the identities, like the reciprocal identity or a quotient identity, if it has squared, as long as you make what you convert it to as square, it's fine. So what I'm trying to say is cosecant squared x is the same as 1 over sine squared x. So that's a reciprocal identity. Okay, and now you should see that as we look diagonally, we're going to be able to cross out. And so it's 1 times 1 over 1 times 1, which is just 1, which is what I wanted. I wanted 1. All right, so again, I cannot stress this enough, right? As you're trying to do these, just be patient, try your best. If it's not going well, start over and use a different strategy. The payoff when you persist through this is going to help so much as you go through and try to do these. I will say in teaching trigonometry, this is where students start to really struggle. And, the persistence is a key issue there. So try to push through. You got to practice, and I'll do my best to support you in that practice. All right, last page. All right, now just a little bit different. All right, it's going to feel very similar for some of these. But these first two here, I wanted to just take a moment and kind of remind you that just because we moved into trig doesn't mean we've lost our algebra skills. So these first two are asking us to take these trig expressions and rewrite them as algebraic expressions. All right, so I'm going to actually end up going back to the trig on both of these, but I will show you the algebra that we'll do in the work. So let's try the first one. The first thing I want to do is actually just have you substitute x for cosine of theta. Because if I do that and make this 2x squared plus x minus 1, I think you'll think, oh, okay, I've factored stuff like this for years in my algebra classes. All right, so what I'm trying to teach you guys and teach our classes with the underclassmen moving up to the upperclassmen is to use the slide divide bottoms up method when I see this 2 in front. So I'm going to slide it to the back and get x squared plus x minus 2. Go ahead and factor this how you normally would. What are factors of negative 2 that add to 1? And that's going to be positive 2 and minus 1. But again, that's not what it is, right? I manipulated the problem to become that. So you've got to put these two numbers that I chose over that number that I slid, which was that 2 in front. The first one is going to simplify nicely. 2 divided by 2 is 1. But because 1/2 doesn't simplify anymore, you actually slide this 2 up to the front. So you get 2x minus 1. All right, so this is what, hopefully, in terms of your algebra skills, you can factor that quadratic trinomial into those two binomials. And so all we would do then is just replace where it says x, we would go back to our cosine of theta. So I'm going to write cosine of theta plus 1 times 2 times the cosine of theta minus 1. Right? And technically, it didn't make me do that because it just wants me to write it as an algebraic expression. But I want you guys to get practice of going back to that, just because when we set this equal to something, you're going to have to keep going. All right? So that's that one. Let's try this one. It's telling us to use the difference of two squares, right? So this is just shouting. As you guys know, I love to shout dots. All right? The difference of two squares. So again, if I change the x to be cosine theta, I have 4x squared minus 1. So if you remember how to factor this, you take the square root of both. The square root of 4 is 2. The square root of x squared is x. And the square root of 1 is just 1. Make one subtraction, make one addition, and you're done. Right? But as I want you to practice is to put the trig back in. So 2 cosine of theta minus 1 times 2 cosine of theta plus 1. All right, and again, you'll see in a later lesson in this unit, we're going to have to solve this equal to some value, and that will require you to have that basic understanding from the first unit as well, the trig basics. So all the stuff we've been doing is building on each other. You can't just forget it now that we've moved to a new unit. All right, let's do 2 more. Simplify this expression by rewriting and using identities. So for this one, the way I'm thinking is I see cosecant is squared, I see cotangent is squared. So my thought is maybe it's going to be one of our Pythagorean identities. So I'll do that work to the side here to see if I can manipulate. And sometimes, guys, I'll be honest, I think it is Pythagorean identity, and then I go to manipulate it, and it just doesn't work. So like you got to get creative. If it doesn't work, maybe try something else. So the one I'm thinking of is 1 plus cotangent squared theta equals cosecant squared theta. So is there a way algebraically I can manipulate this to make it look like what I'm given? And if I subtract cotangent squared theta from both sides, I think I can. So this is going to be 1 equals cosecant squared theta minus cotangent squared theta. And then what do you know in my problem? Right? Cosecant squared theta minus cotangent squared theta. I just manipulated. That is the same as the number 1. So this whole thing just becomes 1 because of all of that work. Okay, let's go ahead and try this last one. All right, so it says, use algebraic techniques to verify the identity. Cosine of theta over 1 plus sine of theta equals 1 minus sine of theta over cosine of theta. So actually, they look pretty much the same in terms of complexity. And there's a couple of ways you could do this. I'll do the way that my brain first went to, which is using my understanding of something that I did in algebra called rationalizing the denominator. Or if you want to think of the way we did this with imaginary numbers, it was multiplying by the conjugate. Now, you may not remember any of this, but it is definitely a trick, a technique that you will need to know and need to practice in order to be successful on doing these. So I'm going to choose the left side. All right, and what I'm going to do is I'm going to multiply the left side times 1 minus sine of theta over 1 minus sine of theta. So this is I'll write it to the side here. My brain is thinking multiply by the conjugate. So you'll notice I just copied it down, but I made the sign in the middle the opposite. So by doing that, what that does is the numerator is just going to be those two things multiplied together. But you'll notice I'm not actually distributing them. But when you distribute the denominator, I don't know if you guys remember this, when you multiply these conjugates from your days in imaginary numbers, is actually the middle term will make 0, right? So when I get to 1 times negative sine theta plus sine theta times 1, those are opposites, and they make 0. So really, this is just 1 minus sine squared theta, all right? And again, as I mentioned, when I see the number 1, and when I see one of our trig functions squared, I'm thinking, maybe this is a Pythagorean identity that I can manipulate. So I'm going to do sine squared theta plus cosine squared theta equals 1. All right, let's manipulate this by subtracting the sine squared theta to the other side. And that leaves me with cosine squared theta equals 1 minus sine squared theta. So when I look here, right, again, do my highlighting, I've got 1 minus sine squared theta in the denominator, which is the same as, after I manipulated it, cosine squared theta. So let's go and replace that, which will be cosine of theta, don't touch the numerator yet, over cosine squared theta. Okay, so that's all that work I did there to replace the denominator. And then the last thing is, oh man, battery's about to die. Gosh, I need to get a new circuit. My last thing is, did it die on me? No, okay. Whew. Don't die. Please don't die. My last thing is, I notice I have a cosine of theta at the top, cosine squared theta at the bottom, and so I can actually, I guess I'll show my work here, right? Cosine of theta over cosine of squared theta equals 1 over cosine theta, right? When you cross out, kind of like your days in algebra or even pre-algebra when you had x over x squared, it's just an x in the bottom. So that means I'm going to have 1 minus sine theta in the top, and in the bottom I'll have 1 cosine theta, which I know it's hard to believe, but that is actually what I wanted in the beginning. I wanted 1 minus sine theta over cosine theta. So we were able to prove this identity. Okay, so as I mentioned on all of these, I'm finished now. They are not simple, guys. This is not simple, and I apologize. This is the first lesson in this new unit, but I just need you to know up front, right, to kind of be ready for how difficult this can be. And we'll be doing practice problems in class. We're going to work hard on the Delta Math links to practice and make sure we're experiencing this frustration and trying to work through it, because that's the only way to get better at this. All right, so good luck.